I agree. But today, the entire lesson is about equilateral and isosceles triangles. So we're going to do the warm-up. We're going to review what those words mean. And then we're going to talk about 2 theorems, one for each of them. Jordan, Chromebook closed.
Oh, wait, so I'm not allowed to look at?
Look at what? No, I want you to listen to me and look at what I'm doing while I do the notes. So let's do the warm-up first. It says, write the equation of a line perpendicular to y equals 5x minus 3 and passing through this point. Okay. Since starting next week, we're going to be proving something every day. We're going to write proofs every day. So what I want us to start doing is when we see a math word that might be helpful, like perpendicular, let's just write down what we know about it. What do we know about 2 perpendicular lines?
2 lines.
They touch each other.
They intersect at, oh, I like Greta's arms. What's this?
Midpoint.
Not midpoint.
90 degrees.
It's like a T.
90 degrees.
90 degrees. Okay, so they form right angles. We don't need that for this problem, but if it said, like, given that 2 lines are perpendicular, when we're proving something, we would automatically want to think right angles. Okay? Now let's talk about it more in context with the problem. Perpendicular lines, how do their slopes relate? We talked about it a little bit every day the past week. They're opposite, reciprocal. Perfect. So here my slope is 5. So if I want the slope of the line perpendicular to it, I need to flip that fraction.
-5.
Not -5. 5 is the same as 5 over 1.
1 over 5.
So 1 over 5, and we make it negative for the opposite part. So reciprocal means we flip our fraction. Opposite means we make it negative. So that's our slope. I now have a slope and a point, x1, y1. It's right here. That's all I need to write a line. You did this in Algebra 1. You'll do it again plenty of times next year. Go ahead, Charlie. Yeah. We need to write the equation of this line, and the way we do that is we use point-slope form. So this is point-slope form. Y minus y1 is equal to m, your slope, times x minus x1. We're going to plug in y1, m, and x1, and we'll get an equation that looks like this after we move some things around, okay? So what would y1 be? What's y1? Yeah, -6. So y minus -6 is equal to, my slope was -1/5, and x1 is -2. Both of these minus and negatives, what do they turn into? A plus. So y plus 6, -1/5, x plus 2. I'm going to kind of hop down here just because I'm a little bit out of room. But now all I have to do is get y by itself. So what I'm going to do is I'm going to distribute my 1/5, my -1/5, and I'm going to subtract the 6 over. So we get y is equal to -1/5 x minus 2/5. That's 2 times -1/5 minus 6, because I'm bringing the 6 over. Last step here is just to combine like terms, this -2/5 and this 6. I know we don't love fractions, but does anyone know how we would write this as a fraction over 30 or over 5? What number divided by 5 is 6? Huh? Yeah, perfect. -30. So -2/5 minus 30/5 is what we get when we make common denominators. Okay? So, final answer, -1/5 x, that's my slope, minus 32/5. Does anyone remember what this 32/5 means? What is it? What does it tell me about my graph?
That's where you start.
Kind of where I start. It tells me that I have a y-intercept at that point. So I have the point 0, negative 32 fifths. So yeah, you would graph that first. You would start there, and then you would use your slope. Questions on the warm-up? Okay, I want you all to take out your Chromebooks, go to Schoology, and in the Unit 4 folder, it says 4.3 exploration. I want you to click on it, but don't touch anything on the picture once you're there. Okay? Then it's alive. But if it dies, then just share with a friend. No worries. Mm-hmm. Yeah. So when you get in, you should have 3 circles on your screen that look like this and match the ones in your packet. Go to Schoology, go to Unit 4, go to 4.3 exploration.
Ryan's cranky. Don't talk to me, Charlie. I'm gonna talk to you while I want.
You can't do that.
Easy.
What
You guys are just agitating each other. Like you
Yeah,
get
we
mad
are.
at each other, but then you do the
It's
same
so
thing
easy
again.
to get him mad.
Right. Just don't let things get to you. What do you say, Ray? Huh?
I'm not mad
It's
because
not embarrassing,
it's
right?
Charlie. It's Charlie. You can be mad at
Yeah, and
Man,
you're
miss.
getting mad at me.
Charlie. I couldn't be mad at you. I'm alright.
Miss.
Matter of fact, I feel bad.
You feel bad for me?
I feel bad.
Oh, you meant into
Thank
this
you.
specific
feel
section.
bad?
Huh? 4.3. 4.3. The rest we'll do next week. I know there's a lot on there. The rest we'll do next week. I want you to click 4.3. If it says sign in, just click continue without signing in and put your name up there. Charlie's almost in. All right. Here's what we're going to do. We have 3 circles right here.
Yes, we do.
If I draw a line from D to C, what is this line on this circle called?
A point.
Oh, it starts with an R.
Radius.
Radius, okay. CD is a radius. What if I draw another line? That's like over here. What's this called?
It's a radius.
A radius. And anytime we go from the center to a point on the outside, we call it a radius. What I want you to do is I want you to draw another radius for each of these circles, okay? Do not make them completely straight lines. So like I would put one point up here and then another point up here. So step 1, here's what I want you to do. I want you to click the segment button right up here. Click it. Now what I want you to do is on each of these points, I want you to connect them. So once you have your segment button clicked, I want you to click point A and point B, and it should draw a segment. And then I want you to click point C and D, and it should draw a segment. And E and F. So we're drawing 3 segments. 3 radii. Once you're done with that, I want you to draw one more on each circle. So I'm going to click point A, and then I'm just going to click a point on my circle. Okay? And I'll click point C, and I'll click another point on my circle. Still on the segment button, you click the middle point and click a point on your circle. Any point. I don't care. As long as it's not in a perfectly straight line. I don't care. Did you actually put one in a straight line?
Silly, silly Rob.
Yeah, he just called you silly.
He's so sad.
When you're done with this, raise your hand so I know you're done.
Oh, I'm sorry.
Okay, last step. What I want you to do is connect those 2 points on the outside to make a triangle. So still on the segment button, I want you to press B and G, and then press D and H, and so on. So you should have 3 circles with a triangle in each one.
Ryan did it perfectly straight.
Mine is not straight.
Okay,
Because he's
are we good up to here?
Yep.
Next step, I want you to hit the more button. Should get a drop down. I want you to scroll down to measure. And what I want you to do is measure each of your radii. So the center point to a point on the outside. I want you to click distance or length. Make sure that's highlighted. And then you click the 2 points you want to measure between. So A and B, I'll click them. And it'll come up with a number. I'll do the same thing for AG and for CD and for my middle point to the outside. I want you to do that for all 3 circles. And
So for all the lines or just?
only the 2 that go from the middle to the outside is fine.
Okay.
You don't have to do the one that actually formed the triangle. I just care about the other 2.
Would it be the same?
Yeah, that's what you're going to notice.
What? That's awesome.
They're supposed to be the
sauce.
same?
Yeah. So what we're finding out is all of these radii are the same. 3.3 and 3.3, 4.9 and 4.9. So each of these triangles is what type of triangle?
Absolute.
Obtuse.
Not obtuse. We have 2 sides that are the same length. 2.
Isosceles.
Isosceles, yes. These are all isosceles triangles. Okay, so we have 3 isosceles triangles. My next step is I want us to measure some of the angles. So, real quick, I want you to just click off distance or length, like unhighlight it, and click just like the cursor button down here. And I want you to delete all of these measurements that you just got just so you can read the angle measures. So like click on them and then click the trash can.
All of them?
Yes. We just found out that all of our radii are the same length. We have 3 isosceles triangles. I want you to delete the lengths. Go back to your measure button. And this time I want you to click measure angle. So this one right here should be
I
highlighted.
don't got a button that deletes it.
You have to click on the cursor first.
You just gotta-
So you got to click
Right.
here. You got to be here, Charlie.
Yeah, I get it.
Okay. Now, what we're going to do is we're going to measure all of the angles in this triangle besides the one from the center point. I don't care about that one. I want you to measure the 2 that are hitting the outside.
Do it right now?
Yep, so to do that, real quick, because we had trouble last time, you have to trace out your angle. So start from the center, and then hit the outside point, and then hit the other outside point. So center, outside, outside. Center, other outside, outside.
Oh, are we doing the angle?
You click the measure button, and then measure angle.
Oh shit, I did that.
So I'm clicking ABG and AGB. I want you to do that for all 3 circles and keep in your head what's happening.
A,
Whatever observations you make, keep them in your head for now.
C, D, G, E, F. Oh.
Your angles are going to be different than mine, but what do we notice about those 2 angles that I made you measure? They're the same. That's what we're going to talk about today. Isosceles triangles have 2 congruent sides and 2 congruent angles. Okay? So that's what we just discovered. So I want you to close your Chromebooks.
But I'm playing a game.
Too late. And then pull your notes packets back out to page 9.
I messed up so
So, I would just so you kind of remember when you go back to look at your notes, I would just kind of draw those triangles that we drew online, draw them in here. You don't necessarily need all your measurements, but I would just draw some triangles in here. Okay, so this is what we did. And what we found out without measurements is that all of these radii were congruent, so we had 3 isosceles triangles. Because we had 2 sides that were congruent, and all radii, that's the plural of radius, all radii, are congruent. So we have 3 isosceles triangles. We found out that we found out that 2 angles from each triangle are congruent. So we found out all of these green ones were congruent to the one in the same triangle. So not only do they have 2 congruent sides, they have 2 congruent angles. So, real quick, this is what we discovered again. We have a triangle, it's isosceles, and we found that those 2 angles at the bottom were congruent. Does anyone remember what the word opposite side or opposite angle means? If I label this side A, side B, side C, and I said, what side is opposite of this angle, what would you say? Yeah, A. It's directly across. And opposite of this angle is B. So in general, opposite of the 2 congruent angles were the 2 congruent sides. So if we tried to kind of summarize this here, we would say the angles opposite the congruent sides of an isosceles triangle are congruent. So anytime we see a triangle, if we have 2 congruent sides, we have 2 congruent angles. Questions on what we just did online? Okay. So again, just a refresher, isosceles triangles have at least 2 congruent sides, and we're going to kind of write names for these sides so we can talk about isosceles triangles a little bit better and easier. So first, the 2 congruent sides, we call these the legs of the triangle. So those are your legs. The non-congruent side we call the base. Hey, easy.
Charlie.
The 2 angles that are opposite the congruent sides and are sitting on the base, so these 2 angles at the bottom here, those 2 angles that are always congruent.
Riley, stop pushing.
Hey, easy. The 2 angles that are always congruent, we call those the base angles. And again, they are congruent. And then the last angle, the one at the top, the non-congruent angle, we call the vertex angle. No, I know, it makes sense for it to be leg angle, but it's not. It's the vertex angle.
Where's that last one, sir?
Vertex angle. Vertex angle. Well, my handwriting, that does, the vertex part is struggling, I agree. Yeah. Yeah, go ahead, bud. Yeah. Okay. Yeah, you're fine. Charlie, stop shaking that. Okay. Questions over these definitions. You'll have to know them. You should be able to identify legs, base angle, vertex angle. Not even close to being done. Buckle up. Next page. This is, listen, hold on, listen. This is the name of the formal theorem for what we just discovered. The base angles theorem. You have to know the name of this theorem. On your cheat sheet, it should say base angles theorem. 2 congruent sides means 2 congruent angles, or something like that, okay? But what this says is isosceles triangles have 2 congruent sides and 2 congruent angles. And that relationship works both ways. So if we start with 2 congruent sides, we use the base angles theorem to get 2 congruent angles. Have a great weekend.
Bye, Reagan.
And if we start with two congruent angles, we use the converse to go backwards and get the two congruent sides. So you have to know both of these and when to use which. So again, these should go on your cheat sheet. The base angles theorem goes from congruent sides to congruent angles.
Did we get it?
No, not yet. You'll get them next Friday. And the converse goes from angles to sides. Okay? Just an FYI for your cheat sheet, it will be both sides this time, and there's going to be a little bit of stuff already typed on it for you. So just, that's coming up next week. So if we label our triangle here, ABC, ABC.
Do you have any other lights?
Huh?
Do you have any other lights?
Yeah, these big ones turn on.
It's dark in here though.
No.
You don't want to see them on. I'll show you after. Hold
No,
on.
I know the sub added more.
Oh yeah, they're terrible. Okay, so, Robbie, if we focus on this picture, if we have AB congruent to AC, if those two sides are congruent, then and only then, so it's an if and only if statement, the angles are congruent. Angle B congruent to angle C. So again, isosceles triangles have two congruent sides and two congruent angles. You have to have that on your cheat sheet. Something about these theorems has to be on there. Okay? Let's use one of the theorems. This says that DE, so this piece, is congruent to DF. So that piece. It says name two congruent angles. What do we think?
FD, ED.
FD and ED are segments. We name, in this case, we can name angles by one letter. So angle blank is congruent to angle blank. Let's think about it.
Angle F, angle E.
Yeah, angle F and angle E. Oh, I thought you said D, sorry. Angle F and angle E, it's your base angles. This one looks a little weird because it's turned a little bit, but if you just turn it straight up and down, it looks just like the picture that we had, okay? So it's the angles opposite the congruent sides, directly across from the congruent sides. So angle F, angle F and angle E. Questions on that one? That's just straight up using the theorem. We can also use it with some variables and some numbers. In this case, again, I have this side congruent to this side. So what do I know about the two angles?
They're both 50 degrees.
Yeah, they're both 50. They have to be the same. They're congruent. 50 degrees. Next one's a little bit different. We have two congruent angles. So what do we know about the two legs, the sides? They're the same, yeah. That relationship works both ways. So here, y is equal to what? 9. So again, we have two congruent angles, so we have two congruent sides. We have two congruent sides, so we have two congruent angles. The last one, these two angles are congruent.
Y equals 12.
How'd you get y equals 12, Robbie? You're right.
Because the other side, because both of the sides are congruent.
Okay, so those have to be congruent, so we set them
And then I did
equal.
4 minus, no, 16, take away 4.
And we got y equals 12. Perfect. So anytime you see an isosceles triangle or two congruent angles or two congruent sides, you're setting things equal to each other, and that relationship works both ways. Questions on that one? That's your first theorem. We have a very, very similar theorem for equilateral triangles. Can anyone remember what an equilateral triangle is?
Equal side.
Yeah, so we would have three congruent sides.
60 degrees.
So three congruent sides. Yeah, Robbie, you're right. Very good. It's the exact same. I mean, if we look here, these two sides are congruent. So hold on. These two sides are congruent, so these two angles are congruent. And these two sides are congruent, so these two angles have to be congruent, and so on. Okay? Shh. So this is a corollary to the previous theorem because we can prove it just based off that theorem. Okay? So it says if a triangle is equilateral, meaning it has three congruent sides, then and only then, so if and only if, it is equiangular, meaning it has three congruent angles. So three congruent sides means three congruent angles. So let's label our picture again, A, B, C. This is also a theorem that should definitely go on your cheat sheet. Again, the main corollary goes from sides to angles. And the converse goes from angles to sides. But in our picture, since AB is congruent to BC, which is congruent to CA, then our triangle is equilateral, so it has to be equiangular. So angle A, congruent to angle B, congruent to angle C. Three congruent sides means three congruent angles. Isaac, close your Chromebook for me. So, let's do an example using that one. What type of triangle is this if I have three congruent sides? Yeah, so three congruent sides means it's equilateral. And if I have three congruent sides, how many congruent angles do I have?
Two.
This is the last
Wait,
page.
congruent angles?
Three congruent sides, so how many congruent angles? Three. Three congruent angles. Which means it's equiangular, if you remember that word. All equal angles. So that means that every one of these angles, angle P, angle Q, and angle R, are all the same. This is just a plain equilateral triangle. I have no measurements. So whatever I get here for these angle measures, it's going to apply to every equilateral triangle. Because this isn't a specific one because I don't have side lengths. It's just an equilateral triangle. So if I have three unknown angles and they're all the same thing, what should I call them temporarily?
Equiangular.
If they're all the same thing, what should I call them? If I don't know what they are, but I'm going to find out. A variable. Like let's call these angles X degrees. Okay?
Can you keep your
So now I have X and X degrees, okay? Those are three angles in a triangle. What do they all have to add to?
180.
180. So X plus X is equal to 180. So 3X is equal to 180. And like Robbie said earlier, X is what?
60.
60. What's up?
Why did we have to go through all that if we already knew if we already knew it was 60?
We didn't know it was 60. We're proving it right now. Robbie just said it, but we didn't know it for sure. I don't trust everything Robbie says.
I don't either.
You shouldn't.
Every single time it's equiangular has to be 60.
Yes. So, what we just did is we said all equilateral triangles. So if you have three congruent sides, they all have interior angles that measure 60 degrees. Charlie, Chromebook. It does. I've asked you 3 times to put it away.
Oh, twice.
Shut up, Roger. Okay.
So, listen. What we just did is if you see a triangle that has 3 sides that are congruent like this, listen, because one like this will show up on your test. What you should automatically think is 60 degrees, 60 degrees, 60 degrees. Always. 3 congruent sides, you have 60-degree angles. Questions on that theorem and how we use it? Okay. I'm going to skip number 2 for now because it's harder. We're going to go to number 3. Isaac, sit down for me. If it's fine with them, who it was bothering before.
Is it fine with them?
Okay. This one. What do I know just like off the bat? What do these red symbols mean?
30.
Yeah. So how many congruent angles do I have? 3 congruent angles. So how many congruent sides? 3 congruent sides. So that means all of these sides are the same. So if 3x and 2x minus 10 are the same, what should I do with them?
Equal.
Set them equal. 3x is equal to 2x plus 10. And again, we're doing this because we're using this theorem right here. If a triangle is equiangular, then it's equilateral. So that's corollary to the converse of the base angles theorem. Okay? Isaac, Chromebook.
I'm trying to see what this used to look like on Google Earth.
Not the time right now. Okay, we have to solve for x. I'm going to subtract 2x over, and I get x equals 10. That's not what the question asks, though. The question says find the length of each side. So what should I do with this x equals 10?
Plug in 3x.
Sure, plug it into 3x. 3 times 10
30.
is 30. So your actual answer is 30 for the length of each side.
Charlie, you get
Did I get that?
that?
Questions on that one?
Did you pick that up? Nope.
Okay, the next one. What are we shown right off the bat? What do the red things mean? Okay, we have 2 congruent sides. If we have 2 congruent sides, what do we know? 2 congruent angles. What theorem tells us that? Is it the theorem for the base angles or is it the corollary? Which one goes from sides to angles?
This
Base.
Base angles theorem. Okay?
Do we have
So-
to memorize that?
Wow.
So here we're using the base angles theorem. And what we're going to do is we're going to set these 2 angles equal to each other. The tapping. So what does x equal?
65.
65, that's it. Okay?
Stop touching.
The next one, again, what do those red marks show me or tell me?
Congruent sides.
So we have 2 congruent sides, which means we have how many congruent angles?
2 congruent.
2, which are these 2. And the reason we can do that is, again, we went from sides to angles with only 2. That's our base angles theorem. So by the base angles theorem, again, what should I do with those 2 pink angle measures?
Set equal to.
Set them equal. 50 is equal to x plus 35. So x is equal to
15.
15. Very good. Second to last example. Here again, these arcs show us 2 congruent angles.
2 congruent sides.
So we must have 2 congruent sides. Which 2 sides?
16 and y plus 4.
Yes, it's the legs. It's 16 and it's y plus 4. So this time we went from sides, or from angles to sides. So we used the converse of the base angles theorem. So, if I'm using the converse, I can set the sides equal to each other. I can say 16 is equal to y plus 4. And we end up getting y is equal to 12. So again, I would just make a note of this real quick. Base angles theorem. That all goes with 2 sides or 2 angles. And the corollary to it works for 3 sides or 3 angles. We use the theorems, so either the base angles or the corollary to the base angles. We use the theorem when we go from sides to angles, And we use the converse when we go from angles to sides. Okay? So for example, if we were proving 3 angles were congruent because we had 3 sides congruent, we would say that is the corollary to the base angles theorem. And if we went the other way, it's the converse of the corollary of the base angles theorem. Okay, it gets a little wordy. Let's finish this one. I would highly recommend paying attention. There are 3 like this on your homework. And if you don't pay attention right now, you won't know what's happening.
Yeah,
Yeah, Caden, turn around.
Charlie pays
Charlie
attention.
I already did it.
Okay.
I already know the answer.
Hold
What's
on.
the answer?
Hold on.
What's the
I'm
answer?
not-
Hold on.
Give it away.
Focus up.
Wait, I don't have it.
Let's look at just the bottom triangle for now.
Whoa, I don't have
I have,
Right, it's the same page.
it's the same page you were just on, bud.
anything.
I have these 2 congruent angles down here. If I have 2 congruent angles, what do I know about my 2 sides? Stop. Stop. We need to stop whining and just stop bothering people, period.
Please.
Okay, I have 2 congruent yellow angles. What do I know? How many sides do I have that are congruent? Guys, I'm looking just in this triangle. My 2 base angles are congruent. What do I know? What do I know about my sides? You just told me 3 times in the last examples.
Wait, okay.
Guys, down here, we started with 2 congruent angles, and we ended up with 2 congruent sides. So up here, we're starting with 2 congruent angles. What should we end up with?
2 congruent sides.
2 congruent sides. Okay. Whew. So this side is congruent to this side. Okay. We also know that we have 3 congruent angles for the other triangle. So if I cover the bottom one, I have 3 congruent angles. So how many congruent sides do I have? Huh?
3.
3. So all 3 of these sides are the same. So what color, if I'm doing color theory here, what color should I draw on the Y and on the 4? If all 3 sides are the same.
Purple.
Yeah, the color that I already have for this side.
Uh-huh.
Blue or purple, whatever color this is. Ah. So everything that's blue is all the same. So what does Y have to be?
4.
4. And what does X plus 1 have to be?
4.
4. So X is equal to
3.
3. There are 2 or 3 like this on your homework. Okay? Questions about today's lesson? Okay, I want you to leave your notes out on your desk for a notes check. If your notes are not ready, just tell me and I won't put them in.
Charlie.
Your homework tonight, listen up real quick. You have 4.3 homework. You also have learning check part 1 due on Monday. So total, less than 20 problems for homework this weekend. You still have 30 minutes to do them. We should be able to finish them all in class. Okay? If you haven't finished your notes, fill those out before I come around and check them.
Did we just not do this part? This, because I have sections.